Hi everyone, welcome back. Today we are solving separate squares 1. So in this problem, we are given a 2D integer array squares, and for each item in squares, we will have x, y, l, in which x, y will represent the coordinates of the bottom left point, and L will represent the side length of the square parallel to the x-axis. Now, we want to find the minimum y-coordinate value of a horizontal line so that the total area of the squares can be split in two equal areas between this line. So if we look at this example, we will split it at y is equal to 1 for the area to be equal, so we return 1. And if we look at this example, we will split right here for it to be equal, so we return this value. And also, the squares may overlap, and when they overlap, they should be counted multiple times. So right here, the width would be 3 and not 2, because they should be counted multiple times. So now that we have seen some examples, let's get to how we can solve this problem. So for this problem, what we can do is we can start at the bottom of the graph and go up and add the areas along the way. So initially the area will be less than the total area divided by 2. And as soon as we add another area that has it greater than the total area divided by 2, meaning that it's time that we can split the line, and then we can derive this equation down to this. So area 2 will be length times width. Now length would be height of B minus height of A. So this would be like one y-coordinate, and this would be like another y-coordinate, and then this will derive to this if we want to put height B on one side. So we need to subtract area 1 here and then divide by width and then add height A. So now height B is on one side, and then if you multiply the numerator and the denominator by 2, then it will look like this. So once we have found an area that's larger than the total area divided by 2, then we can plug in this formula to figure out the minimum height that we can have for the total area above the line and below the line to both be equal. So what we can do is we will first create an array consisting of the y-coordinates, the length that the square of that y-coordinate has, and plus 1, meaning that we are adding to the area. Now we will also need these type of items because as we move up, the width may need to be subtracted. Like right here, we have a width of 3, but when we're up here, the width is only 2. So we will need these type of items to keep track. And after we have made the array, we will sort the array according to the y-coordinate, and then we can iterate through the array and calculate the area accordingly and add to the accumulated area. And as soon as the accumulated area is larger than half of the total area in the graph, then we can plug in the formula that we have derived earlier to find out the minimum height that can draw a horizontal line to split the graph into two equal areas. So now let's go over this example. So first we will set up the events array. So we see there's 0, it has a length of 2, and we are adding, and for this box it's at 1 1 for the bottom left, it has a length of 1, and we are adding. And then when we get to y is equal to 2, we will have to subtract a width of 1, and for this box we will have to subtract a width of 2 when we get to y is equal to 2. So as we can see, the total area divided by 2 will be 2.5 because the total area is 5. Now first come here, the area is 0 at the very bottom left corner obviously, so we don't add anything to the area. Now we see that the length has 2, so we will change the width to 2, and now we come to the next one. It will have a height difference of 1, so we change height to 1, and 1 times 2 will have an area of 2, so we add 2 to the current area, and now we can edit the width at 1. It will have a length of 1, so we need to add 1 to the width, so now it has a width of 3. Now we move on to the next one. Now the height difference is still 1 because 2 minus 1 is 1. Now if we see the height difference multiplied by covered width, it will have an area of 3. So if we add 3 to the current area, it would be greater than 2.5. So now we can plug in the formula that we derived earlier. So 1 plus 5, the total area, minus 2 times 2, which is area 1, divided by 2 times 3, which is the width, and then that will give us 1.16667 as our result, and we can return that. So the time complexity would be O of n log n because it will take n time to sort the events, and the space complexity would be O of n because this events array can take up to n space. So now let's get to the coding part. So first we will define total area to 0 and events to an empty array. Now we'll need to fill out events. So for square in squares, y length will be sq1, sq2, and we will update the total area by multiplying the square of it. So length times length. Now we'll append YL1 to events, and we will also need to append Y plus L, comma L, comma -1. And now we will sort the events. Now, in case if you want to, for the bottom part, if you wanted to match the equation that we derived earlier, you can write the variables like this. Alright, let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.